In sections 10.3 and 10.4, we're going to go over solving problems with right triangles and oblique triangles. A right triangle has 6 parts, 3 angles, a right angle and 2 acute angles, which are angles less than 90 degrees, and 3 sides, the hypotenuse and 2 legs. We can use the trig ratios that we went over in the previous sections to find all the unknown sides and angles of a right triangle if we know either of the following 2 combinations: the length of one side and the measure of one of the acute angles, or the length of any 2 sides, including hypotenuse. Here's an example. We need to find side B in the triangle, given angle A equals 50 degrees and hypotenuse C equals 21 centimeters. We're going to use a 3-step approach. First, we're going to decide which trig ratio to use based on the information we have. We're given one of the acute angles, 50 degrees, and the hypotenuse, 21 centimeters. We need to find the adjacent side to angle A, which is side B. The cosine relates the adjacent side and the hypotenuse. Remember, in SOHCAHTOA, CAH, cosine equals adjacent over hypotenuse. And in this case, that's side B over side C. Next, we need to write the equation with the known quantities. Cosine of 50 degrees equals side B divided by 21. Now we solve for the unknown quantity B. Find cosine of 50 degrees on your calculator and solve. The cosine of 50 degrees is 0.6428 equals B over 21. We multiply both sides by 21 to clear the fraction, and the result is B equals 13.4988 centimeters, or rounded 13.5 centimeters. For this triangle, given angle A is 42 degrees, and side A is 12. Find side C, which also happens to be the hypotenuse. Try it on your own, and then we'll go over the solution. You have an angle, and you have the side opposite the angle. So you have the angle 42 and the side opposite A, 12. You want to find side C, which is the hypotenuse. The sine ratio has the opposite side and hypotenuse in its terms. Sine A equals opposite over hypotenuse. Substituting, sine of 42 equals 12 divided by hypotenuse. Solving for hypotenuse, which is side C, we get side C equals 17.93 inches. Now we're going to talk about oblique triangles, which are triangles with angles greater than 90 degrees. These triangles do not have a 90-degree angle. We've seen how we can solve right triangles using the trigonometric ratios, but we can't use the trig ratios to solve oblique triangles. We need 2 more formulas, the law of sines and the law of cosines. The law of sines, sine of angle A over side A equals sine of angle B over side B equals sine of angle C over side C. We can use the law of sines to solve 2 specific cases of oblique triangles. The first case, 2 angles and a side are known, and in case 2, 2 sides and the angle opposite one of the known sides is known. First case, 2 angles and a side are known. First, we'll find the third angle by subtracting the 2 known angles from 180 degrees. Remember, no matter what type of triangle you have, the sum of the 3 angles always equals 180 degrees. Then we're going to use the law of sines to find the other 2 sides. For a triangle with angle A equals 47 degrees, and angle B equals 38 degrees, and side A equals 8 inches, find all the unknown parts, and for this, the unknown parts are angle C, side B, and side C. So we're going to find the third angle by subtracting the 2 known angles from 180. 180 minus 47 minus 38 equals 95. So angle C equals 95 degrees. So we have our first unknown, and that's angle C. Set up the law of sines with all the parts that you know. Sine of 47 over 8 equals sine of 38 over B equals sine of 95 over C. Now we can use two ratios at a time to solve for the unknown. So first we're going to solve for side B. So we're going to use the A ratio equals the B ratio. Sine of 47 over 8 equals sine of 38 over B, the unknown. Now we're going to rearrange to solve, and we get B equals 6.7 inches. To solve for C, again, we're going to use two ratios, the A ratio and the C ratio. Sine of 47 over 8 equals sine of 95 over C. We're going to rearrange to isolate the C on one side, and solving, we get C equals 11 inches. In case 2, two sides and the angle opposite one of them is known. This case is a little more complicated because there are three possible solutions: no solution, one solution, or two solutions. Your calculator will automatically give you the correct solution. Suppose that angle A equals 109 degrees, side A equals 14.8 inches, and side B equals 19.5 inches. We're going to substitute these values into the law of sines. Sine of 109.0 degrees divided by 14.8 equals sine of B divided by 19.5. Now we're going to solve for sine of B, but that equals 1.25. The sine function cannot be greater than 1, so this triangle has no solution. Your calculator will give you an error message because it can't solve a problem with a sine greater than 1. Here's a problem for you to try on your own. Given angle A equals 121.4 degrees, side A equals 28.4 centimeters, and side B equals 11.2 centimeters. Find all the unknowns: angle B, angle C, and side C. Let's look at the solution. Using law of sines, we're going to use the A ratio and the B ratio. Sine of angle A over A equals sine of angle B over B. Substituting what we know, sine of 121.4 divided by 28.4 equals sine of B divided by 11.2. We can solve for angle B. Sine 121.4 times 11.2 divided by 28.4 equals the sine of B. The sine of B equals 0.3366. Now you have the sine, but you want the angle. In order to take it from the sine to the angle, you use the arc sine, or sine to the -1 on your calculator, which is the function above the sine key. When you put that into the arc sine function, you get the angle B equals 19.7 degrees. We know two angles, so we can find the third angle C, again, by subtracting the two that we know from 180. Angle C equals 180 minus 121.4 minus 19.67, so angle C equals 38.9 degrees. And again, we're going to use the law of sines to find sine C, and we're going to use the B ratio and the C ratio. So substituting, sine 19.67 divided by 11.2 equals sine 38.93 divided by side C. And now we can solve for side C, and we get C equals 20.9 centimeters. Now let's move on to the law of cosines. In addition to the two cases we can solve using the law of sines, there are two additional cases for oblique triangles we can solve using the law of cosines. These are cases where the law of sines won't work. The law of cosines has three parts. A squared equals B squared plus C squared minus 2BC cosine angle A. B squared equals A squared plus C squared minus 2AC cosine angle B. And C squared equals A squared plus B squared minus 2AB cosine angle C. And for case 3, we know two sides and the angle included by the sides. So that means we may know B and A, and the angle included by the sides would be C. And then in case 4, we know all three sides. Here's an example. Solve the triangle with side A equals 22.8 centimeters, side B equals 12.3 centimeters, and angle C equals 42 degrees. So here we know two sides and the angle included. First, solve for side C using the law of cosines. Equation, c squared equals a squared plus b squared minus 2ab cosine of angle C. Substituting, c squared equals 22.8 squared plus 12.3 squared minus 2 times 22.8 times 12.3 times cosine of 42 degrees. Using your calculator, you get c equals 15.9 centimeters. Now, when you multiply all of this out on your calculator, you're going to get c squared, and in order to get c, you have to take the square root of that number. Now that you have all three sides and one angle, you can use another one of the law of cosine equations to find the other two angles. So to find angle B, we're going to use the equation with cosine B. B squared equals a squared plus c squared minus 2ac cosine of angle B. And we're going to substitute. 12.3 squared equals 22.8 squared plus 15.9 squared minus 2 times 22.8 times 15.9 cosine B. Solve for cosine B, and we get cosine B equals 0.857. Now we need to go from cosine to the angle. Remember, you're going to use cosine to the -1 on your calculator. So punching that into your calculator, you get the angle B equals 31 degrees. You don't have to use the equation to solve for A. We just need to subtract angles B and C from 180. And when we do that, we get angle A equals 107 degrees. Using law of cosines, solve the triangle if you're given angle B equals 34.4 degrees, side A equals 145 feet, and side C equals 112 feet. So stop the video, try the problem, and then we're going to look at the answer. To find side B, use b squared equals a squared plus c squared minus 2ac cosine angle B. Substituting given info, b squared equals 145 squared plus 112 squared minus 2 times 145 times 112 cosine 34.4. We get b squared equals 6,769.31, and we have to take the square root to get to b. Taking the square root, we get b equals 82.3 feet. Now to find angle A, we're going to use a squared equals b squared plus c squared minus 2bc cosine angle A, and we're going to substitute the given information. 145 squared equals 82.3 squared plus 112 squared minus 2 times 82.3 times 112 cosine of angle A. That equals negative 0.0926, and now we take the arc cosine, or the cosine to the -1, and we get angle A equals 95.3 degrees. And we can find angle C by subtracting angles A and B from 180. Angle C equals 180 minus 34.4 minus 95.3, which equals 50.3 degrees.